purpose of this video tutorial is to show how to model upturned beams or beams where the flange has been dropped below the top of beam in ADAPT PT 2010. In this example, we'll go ahead and select beam, and the default option is to consider effective width and bending. So if we proceed over to the span geometry and we select section, we can see that the two bottom sections, the I and L and the T sections, are grayed out. You cannot use those with the effective flange. So going back to the input, we'll select no. And now if we go to the section input, we can select either of these two. So in this case, we're going to select the extended T section. For the length of span, we'll say is 40 feet. The width of the section will be 12 inches. The height of the section is going to be 36 total. The B sub F, which is the top flange dimension, in this case we'll say is 200 inches. Now this is actually going to be greater than the real width of the slab that we want to model that's down from the top of the beam. So for the height, H sub F, we're going to say that that is also 12 inches. The B sub M, we're going to say is 178 inches. This is the actual depth of the width of the slab that we're going to model. And then the height to the bottom of that slab is 24 inches. So if we look at a view, we can see that we have this slab on top of the actual flange that we want to reduce in width to equal the stem width below. So to do this, we need to go back to B sub F and now change this back to 12 or to whatever value we want. It could be 24. And now we have an upturned beam where we have the flange lower than the top of the beam. The key is to enter B sub F as a value greater than the actual flange width, and then to go back and change that. Once you've done that, you can proceed with your design.